Well, you may have heard that we have some issues with honeybees, not merely in Ohio, but elsewhere on the planet. So in this last module, we're going to look at whether or not there is a problem. If there is, just how bad is it? And what does it mean to agriculture, first of all, to the ecology of the planet as we know it, and then ultimately to regular human beings like you and me. What does it all mean to say that bees are imperiled and are not doing their regular jobs as a result of their numbers being lowered? So we'll look at exactly what the nature of the problem is, how far the impact extends, and what, if anything, we can do about it. This module is coming at you in 4 parts. First, we'll look at what those wonderful little bees do for us. Then we'll look at the process of pollination and address the issue of why we should care about pollination and what, if anything, it has to do with bees. Hint, it does. Then we'll look at the nature of the crisis with emphasis on what's going on in Ohio. And finally, look at some steps that we can take to ameliorate the bad stuff and return to a more normal state of affairs. So basically we're going to be looking at honeybees in Ohio and by extension around the world and ask the question, is there a crisis? Now throughout this presentation you're going to be seeing some beautiful photographs, and I want to give credit to the photographer whose name is Karina Weatherby. She is a professional photographer, the owner of Photo Brilliance, and it is largely her pictures you're going to be seeing today. And here are some of them. So most of you probably know that honeybees are really valuable to us for a variety of reasons, one of which is that they're critical to the ecology of the planet. And this is primarily because they offer what we call pollination services, which allow the pollination of particular species of plants so that they can produce seeds and ultimately fruits, many of which we like to eat. So here are several examples of flowers or fruits that are pollinated by honeybees. You can see that it includes cherries and watermelons and sunflowers and apples. And that's not all. In Ohio, the state in which we reside, in the neighborhood of 30% of crops require honeybees for pollination. So it's not an insignificant contribution to our agricultural productivity. There certainly is variation among crops with respect to their dependence on honeybees for pollination. And here's a graphic that summarizes that differential dependence. If we look at almonds at the top, their production brings in about a little bit over $2 billion per year, or did in 2006. I assume it's higher now, both because the honeybees have made the almonds less plentiful and inflation increases prices over time. But you'll note in the last column, where it assesses the percent honeybee pollination required, you'll note that the almonds have an absolute 100% requirement for honeybee pollination. So if there are no honeybees, there will be no almonds. Apples come in next. They require about 90% pollination by honeybees. There are other mechanisms for pollinating apples, but the preference definitely is for honeybee pollination. Oops, stop that. Cotton has a smaller requirement for honeybee pollination. It's only about 16%, but where it is required, where it is needed, it is a significant demand on honeybees. Blueberries also are 90% pollinated by honeybees. When we get down to some of the other fruits and vegetables, things like soybeans, peanuts, strawberries, there's a minor requirement for honeybee pollination, but they can be pollinated through other means. So it varies by crop, but in many of the crops that we anticipate being able to buy when we go to the grocery store, there's a major reliance on bees for that pollination services, and all told, those pollination services are estimated in the neighborhood of $16 billion. So again, not insignificant. It's also, I think, useful to point out that while we've been focusing on agricultural crops, and usually we do when we talk about honeybee pollination, there are also a whole bunch of plants in the wild that are pollinated by honeybees, without which the entire food chain would be disrupted. So if we simply look at the requirement of honeybees for pollinating a plant like clover, which you see represented in the middle, you would impact a whole bunch of other things if that honeybee were removed and the clover could not be pollinated. For instance, you wouldn't have some mites, not that we care particularly, but in the scheme of things ecologically, they're necessary for some things. We might have fewer deer. Now, deer can eat clover, they can switch to other things if they don't have clover, so maybe the impact would be less than absolute, but nonetheless there would be an impact. Likewise, bunnies like to chew on clover, and cows like to graze on clover, and well, I guess these are elk or something, also want clover. So there would be a very widespread impact if we didn't have wild pollinators to participate in the food chain. Honeybees do other things for us besides produce honey. Over here you see a lovely jar full of honey which is being dripped on a biscuit, which is how we like to have them often because biscuits are kind of boring otherwise. And honeybee is the main crop, honey is the main crop that we associate with honeys. But they do other stuff as well, like produce this thing called mead, which is an alcoholic beverage prepared from honey. And it's rather good. We have a local establishment called Brother Drake's Meadery where you can buy some mead. It's a very nice alcoholic beverage that has a fairly significant market associated with it. But this is not all that honeybees do for us. We can extract honeybee venom. It's useful for a variety of purposes. Medicinally, one of which is to habituate people who are allergic to honeybee stings to the venom so that if they are subsequently stung by a bee, they will not be killed by it. That's a useful thing. Bees produce wax. Wax can be used for a whole bunch of different things, like freeing up rusted metal bolts, which is very useful, waterproofing leather. We can make candles out of the wax, which is a nice thing to have. You can use it to finish bare wood. There's some pharmaceutical uses. You might be able to wax your skis with it. I don't know if there would be any reason not to. It is a wax after all. So there's a bunch of stuff you can do with honeybee wax, which the bees are, of course, making for their own hive, and it's a structural component of the hive for the bees. And lastly, we have this thing called propolis, which probably most of you don't know about. Bees use propolis by taking resin out of plants and trees, and they modify the material chemically and then are able to use it for structural purposes within the hive, such as the sealing of holes. But we also know that the propolis has antibacterial and antiviral properties that can protect the hive from being septic, and so we can extract that and use it for its antiseptic properties by humans. It's alleged that the propolis has the ability to prevent the formation of dental plaque, and the National Institutes of Health rates propolis as being possibly effective in the treatment of cold sores, genital herpes, and also post-surgical mouth pain. So the point is that bees do a whole bunch of things in addition to producing honey that are useful to us as human beings. So again, we should revere honeybees for a variety of reasons. Now, with respect to honey and its economic impact, we know that domestically within the U.S., honey comes from roughly 135,000 beekeepers who collectively care for 2.4 million colonies in the United States, or those are the figures. As of 2006, it's remarkably difficult to get current figures. We know that in 2007, almost 150 million pounds of honey was produced domestically, and that had an approximate value at about $150 billion. Honey is becoming less competitive. That is to say, domestically produced honey is becoming less competitive with foreign honey because of the pollination shortage that I alluded to at the outset. In addition, the value quoted on the slide, the $150 billion, includes the other kinds of products that can be produced from bees. Honey, candy made from honey, beeswax, propolis, pollen, etc. So why should we care about pollination in the context of honeybees? Well, pollination is obviously important to our economy and also our ecology. And to the extent that honeybees are required for pollination, and as an aside, there are other ways to secure pollination services. Wind can be a pollinator. Water can be a pollinator. There are other organisms besides honeybees that can pollinate things. But some crops, and you saw the table several slides ago, have a fairly high requirement for specifically honeybees. So that's why we're concerned about the lack of honeybees compared to historical averages. So let's learn a little bit about the nature of pollination so we can understand the role that honeybees play in that pollination activity. And this gets to an ecological question, and it involves flowering plants, which we know scientifically as angiosperms. Angiosperms are the flowering plants, and they're a major evolutionary advance. And that is due to the flowers, because the flowers provides a site where reproduction can take place and also a means to protect the embryos, plant embryos or seeds, so that they can secure the means to survive and to produce the next generation. So the flowering plants are a major evolutionary advance and ecological success, largely due to the fact that they produce flowers. But having flowers means that pollination via some mechanism, whether it's honeybees or wind or water, will be required. And that's one of the reasons why honeybees are so critical. The plants that require honeybees require them often to a great extent. And without the honeybees, the plant can't complete its life cycle to produce seeds and fruits and ultimately to produce the next generation. So, some plants, here we see a lovely flower, require, this is annoying as all get out. Come on. Sorry about that. A lot of plants require honeybees. Some plants use honeybees but don't require them. There are what we refer to as incidental pollinators. Here you see a spider that's climbing all over this plant, and in the process of climbing around the plant looking for something to eat, it might accidentally or incidentally pick up some pollen from one of the flowers and then rub it on the female reproductive parts of another flower and secure the pollination services that the plant needs. So honeybees can do it, other arthropods can do it, and some other animals can do it, as we'll reveal in a couple of minutes. Now this is a slide that's very congested, but don't be afraid. We'll walk through it, and it's not as bad as it looks. And this covers the nature of pollination, and to understand it, you need to know that flowering plants produce both male plants, and they have a sex organ, which we call the anthers. So here you see anthers on a male plant. And they also produce female plants. Here we see the female plant, and the operative organ here is the carpel, which is in the center, right here. It happens to be surrounded by anthers, which makes it very convenient because this plant probably would not require honeybees because the pollen produced by the anthers would sort of fall off onto the carpel, and that would secure the fertilization. But other plants have the male and female reproductive plants, flowers on different plants, and so they would require something more creative to secure fertilization. One of the ways of doing this, as we already know, is to have a honeybee crawling all over the flower. In so doing, it's going to rub up against the anthers, which contain the male reproductive gamete, which we refer to as pollen. And a honeybee has a lot of hair all over its body, and they're sticky hairs. So when it contacts the anther and the pollen, it can be transferred to the honeybee. And when it proceeds to go to another flower, it can deposit the pollen on another flower, on another plant, and that secures the pollination that it needs. So honeybees are very helpful in moving pollen around from one flower to the next in order to help the plant reproduce. And the plants participate in this arrangement. Plants will produce specific colors that honeybees find attractive. This beautiful purple is something that the honeybees see in a different way because their eyes are not like ours, and the spectrum of light and colors that they can see is different from ours. But often you'll find, if you can look at a flower the way the honeybee sees it, and there is a diagram of this for you in the book, you'll note that it appears much different than we see it. Stop it! There we go. And that is often because in the UV range, which the honeybee can see in, the flower looks different, and often it'll be marked in a way that kind of guides the honeybee to the reproductive organs of the plant so that it can rub up against the pollen and transfer it to another flower. It's a really ingenious system. There's coevolution between the flowers and the honeybees that make the interaction beneficial for both parties. So the bees are very successful in moving pollen around to help the plants reproduce. Butterflies can do this too. Butterflies are enticed by flowers to rub against their reproductive parts by having nectar within the flower, which the butterfly will recover by inserting its very long curled proboscis or mouth part into the essentials of the flower. And its goal, the butterfly's goal, is to take the nectar up and use it as a food source. But in so doing, it rubs up against the reproductive parts of the plant, and that accomplishes the pollination. So butterflies are also very helpful in transferring pollen. And here's what's going on. So down here we have a graphic that summarizes why this is important. We have the pollen from anther organs here. We have the carpel here from the female flower. And what happens is that if the pollen contacts the carpel, a single pollen cell will alight on the tip of the carpel, which is also called the stigma, and germinate. By germinate, what we mean is that the pollen grain in contact with the stigma will... Stop it! I'm so sorry. The pollen grain on the tip of the stigma will sprout or germinate a pollination tube which penetrates down through the carpel and reaches the inner sanctum here, where the female sex cells are located, and fertilization will take place, resulting in an embryo. I'm just skipping a bunch of steps here so you don't have to deal with all the mitotic and meiotic divisions. And the embryos will become the seeds. So if you were to take this organ and look at it in reality, this is a fruit that's been cut open. The seeds are the embryos that are produced by fertilization, which is what happens when the pollen sends its pollination tube down into the carpel, fertilizes the female gametes that are in there, resulting in some meiotic and mitotic divisions that produces the embryo, which we know as seeds. So that's why we're concerned about all of this, and I apologize for the fact that the slides keep moving on their own. Now, as I mentioned, there are many ways to achieve pollination: wind, water, and a whole bunch of different kinds of pollinators, which begin with honeybees and also wild bees. There are many bees in the wild of various different species that can do roughly what honeybees do for us. Also hummingbirds. Hummingbirds are after the nectar of flowers, and so they do basically what a butterfly does and also transfer pollen in the process. And then, out there in nature you got big mammals lumbering around, bumping into plants, helping to spread the pollen either by making it come loose from the anthers and blow in the wind, or simply by rubbing it up against like the bear fur or the dog fur, and then when they encounter another flower of the same species, the pollen might brush off onto the second flower and fertilize the flower. But the point I want to make to you now is that in the neighborhood of 30% of our agricultural crops require some level of honeybee pollination. So it's not only an ecological benefit to have honeybees, but also an economic one. So, why do I bring this up? Why do I allude to there being a problem? Well, here's the deal. Back in the years 2005 to 2007, there was a massive die-off of honeybees. It was completely unexpected, and it was very dramatic when it took place. We named the crisis Colony Collapse Disorder, or CCD, and during those years in Ohio alone, the number of active beehives went from a high of 21,000 in 2005 to 15,000 in 2007. So that was a huge decline. And that's simply the number of hives that were lost in toto. There were also hives that weren't completely lost, but had a severe decline in the number of bees within the hives. So it was a big problem in Ohio, and it also radiated around the planet. And we saw hive reductions of 50% or more in many parts of the U.S. and also in Europe during those years. So it was a big, big deal. As a consequence of colony collapse and the cries of anguish that went up from the agricultural community, then Governor Strickland decided to convene a special task force to study the nature of the crisis in Ohio and decide whether colony collapse disease was in fact a crisis. So to do this, he composed a panel composed of all of the major stakeholder people from agriculture, those who were concerned ecologically, politicians of different stripes, and that is to say, Governor Strickland intuited that it would make sense to go to OSU and select the chair of the entomology department as the co-chair of the committee. The other co-chair was one of the directors of the Ohio Department of Agriculture. At the time, I was the chair of entomology, so I became the other co-chair of the task force. The task force was given 5 different questions to study. First, is there a honeybee crisis in Ohio? If so, what is the nature of that crisis? Secondly, are there pollinator shortages in Ohio sufficient to affect crop production? Third, we were to review and provide an overview of a prospective honeybee emergency action plan. We were to review various initiatives at the state and federal level on honeybees and provide a 5-year plan for the restoration of bee populations in Ohio. Now, I'm not going to put you through all of these, but we are going to look at the first 2 questions in the rest of today's presentation. So, question 1, is there a crisis? And if there is, what are its components? The consensus of the task force is that, yes, there is a crisis in honeybees in the state of Ohio. And we examined in some detail its likely cause and determined the same thing that other bee people had also determined, namely that it is not due to a single factor, but rather to a whole bunch of interacting factors, which makes it hard to diagnose and hard to treat. But if you look historically at honeybee populations in Ohio and elsewhere, you will notice the following things. In Ohio, back in the 1940s, there were 330,000 beehives, but by 2009, there were shy of 15,000 beehives. So that represents a 95% decline in beehives in Ohio in a 60-year period. The reason for this, well, there isn't a single reason, there are multiple reasons, but generally speaking, the decline in beehives has paralleled particular societal changes, such as the reduction in family farms. It used to be fairly normal for a farm that grew agricultural crops to have a small number of beehives on the farm to provide pollination services. Another factor that has mitigated against beehives is that as urban dwelling has expanded into agricultural areas, there's been reluctance to keep beehives even on farms because, as you know, sometimes people are litigious, and if somebody gets stung by a bee, even though the urban dwellers have moved into an agricultural area and should be willing to accept some level of inconvenience from things that are agricultural, nobody wants to be dragged into court over the fact that somebody got stung by a beehive. So the general litigiousness of society has mitigated against people keeping bees. There's concern about the Africanization of bees. Africanized bees exist. They exist in South America, primarily in this part of the world. They're a warm weather species, but they're also highly aggressive, and they can crossbreed with domestic bees. So there's concern that over time, the domestic crop of bees in places like Ohio might become Africanized, which would make them more aggressive and lead to more stings, and to the extent that people are willing to sue over such things, greater litigiousness. So these are all reasons why people have stopped keeping bees in the numbers that they had back in the 1940s. And even if people are keeping bees, whether they're agricultural or just a domestic beekeeper, the average number of hives being kept per person has gone down. So all of these things create the background against which colony collapse has played out. We also know that historically, and certainly over the past century, where we've been studying it and recording the results in the scientific literature, we know that honeybee hives are just routinely plagued with problems. So this includes a bunch of parasites and specific diseases. For instance, American foul brood, or AFB, is caused by a bacterium that invades the honeybee hive, and it causes some fairly dramatic results, mostly honeybee death. And if you were to go to a typical beehive in the state of Ohio at this moment, you would probably find the American foul brood spores in virtually every one of those hives. But it generally doesn't become a problem until the hive becomes stressed, at which point the disease will manifest itself. It's treatable with antibiotics and also by maintaining strict hygiene. If you have sick bees, you get rid of them. But the normal practice is to destroy any hive that is found to have the American foul brood spores, because it is very contagious and hard to prevent transmission. Unfortunately, the fact that the normal reaction to the presence of the spores is to eliminate the hive has had the unintended effect of reducing people's receptivity towards having their hives inspected, which simply makes it more likely that when the hives get stressed, they will manifest the disease. In addition to pathogens, honeybees can be infested by two species of mites. The first, varroa mite, is an animal. You can see a little mite right here on this honeybee. And what the mite is doing is feeding on the bodily fluids of the bee during its entire life cycle. So throughout all of the different life stages, the mites will feed on the bees. In addition to doing that, the varroa mites also serve as vectors of viral diseases. Here's the result of one of them. This, you can see that the mites are on the thorax of the bee. You can see that the bee is infested by multiple mites, and it has also gotten this viral disease that causes its wings to be deformed. So you can see that they're crumpled, that they're unable to expand out to their normal width and depth, and so this bee will not be able to fly. So again, this is largely a problem when the hives are stressed, but they're stressed enough now that it tends to be a disease that you will see if the spores are present. The other mite that is operative in domestic beehives is the tracheal mite. You remember that the tracheal system is the respiratory system of the bee, of the insect. And in this case, the respiratory system, the trachea, has been extracted from the bee, and you can see that there's a whole bunch of little mites within that tracheal system causing major problems for that bee. So inside the respiratory tract, it will decrease survival, and that, of course, will impact the entire hive. Finally, there's a fungus, given the name Nosema, which has caused major problems in honeybees. It affects the digestive tract of the adult form. It increases mortality, and also it decreases honey production. Some of the ancillary effects is a reduction in the royal jelly production, which is required for reproduction, and that, of course, will reduce the strength of the hive next year by making it difficult to replace bees that have been lost. Unfortunately, it's also highly contagious, and once it's there, it's very easy to spread to other hives. Again, it's exacerbated by things like bad weather that put the hive under stress and increases the likelihood that the bees will manifest the disease caused by the fungus if it's present. So on top of all of that, in 2005, we then encountered colony collapse disorder, whose cause, or maybe we should say causes, are unknown, at least at this point. But we have a bunch of hypotheses about what it might be. The phrase colony collapse disorder is what we use to describe the massive sudden die-off of bees, as took place between the years 2005 and 2007. But this sort of thing, the massive die-off of bees, has been reported pretty much throughout the history of beekeeping. So colony collapse disorder is something that probably has happened before, although we gave it a different name when it happened previously. The causes of colony collapse may include things like a pathogen. The Israeli acute paralysis virus is one virus that has been associated with CCD sometimes, but not others. Pesticides have been adduced as a probable cause. The compound imidacloprid particularly has been indicted as a potential causal agent, but again, it's seen in association with some hives that are affected and not others. Bad environmental conditions like prolonged cold have been suggested, and even some exotic kinds of things, cell phone towers, transgenic crops, and various others have been suggested. So all of these things are on the table, but the problem is you can find one or more of these things taking place in some affected hives, but not others. So it just isn't clear what the lead cause is, much less what the complete answer is to CCD. So the consensus view of the problem is that colony collapse disorder is due to multiple causes, but that the contribution of specific causes can vary geographically and also over time. So it's a very nondescript problem. Or maybe we should say it has too many descriptions. We know that the effects of CCD, wherever it is to impact the beehives in such a way that honey production, which is the main crop we associate with honeybees, will be reduced. And since most of it has happened domestically in the United States, it did go to Europe, but that was a secondary manifestation. What has happened in the United States as a result of CCD is that we're increasingly importing more honey from abroad, since the major harm has been to domestic producers of honey in the United States. We know that U.S. honey consumption is about a pound per adult per year, or roughly 323 million pounds, which is the population of the U.S. We know that at the moment we can produce somewhere around 150 million pounds of honey domestically, which means that we're importing the balance. And unfortunately, because the domestic honey is cheaper and we don't tax it coming into the United States, there's sort of a negative feedback cycle. When people start buying foreign honey because it's cheaper, they tend to continue to buy it because it's cheaper, and that then means that there's less of a market for it in the U.S., and so people produce less honey in the U.S., and it's sort of a downward spiral. Now, elsewhere on the planet, the word crisis is not enough to describe what's going on with respect to honeybee populations. In China, not throughout the entire country, but in some major agricultural zones in China, there are literally no honeybees. None. Zero. Zip. Nada. And it's due to a variety of things, including colony collapse, but also due to some wretched environmental conditions that are now present in China due to its rapid industrial expansion without any real environmental pollution controls. And one of the major impacts has been to eradicate honeybees in big parts of China. And so what you see here is the way they have to grow almonds now in China. You remember from the table I showed you early on that almond trees have a 100% absolute requirement for honeybee pollination. And in those regions where there are no honeybees in China, the only option they have left is to have people armed with paintbrushes climb the almond trees and hand pollinate the almond flowers. As you can imagine, this is a very labor-intensive, expensive way to procure almonds. But that's what they're doing in some parts of China now because of the loss of honeybees entirely. Now, the second question we were asked to examine is whether or not Ohio itself is being affected by having too few bees to pollinate its crop, its various crops. You remember that roughly 30% of Ohio crops are pollinated to some degree or another by honeybees. And the major finding is, yes, despite the fact that there are commercial hives available for hire, there aren't enough of those hives to go around. So the number of beehives we have left domestically in Ohio simply isn't enough to do the job of pollinating all of the crops in Ohio that need to be pollinated. In 1998, we had 2.5 million hives, but some of those are the traveling hives that commercial producers hire in other states and that we move around to participate in that pollination activity. So, of the 2.5 million hives available in Ohio in 1998, about a third of them were transported elsewhere, particularly to California, to pollinate, wait for it, almond trees. The number of rental hives is down nationally due to colony collapse disorder. And also, the price of renting one of those beehives has increased dramatically. Back in 98, the cost of renting a hive was $50 per hive. However, that tripled overnight as a result of colony collapse disorder. So now it costs $150 per beehive. Another problem is that we, as a society, have allowed for the hives to be transported around the nation. So they originate usually in some sort of warm place, North Carolina, South Carolina, Florida, Georgia, those places, because the bees come out earlier since the weather is warmer down there, and then they can be deployed, if they're being rented, they can be deployed across the country as the weather warms up across the country and the plants start to flower. But here's the deal. There is no provision, either federally or at the state level, for inspections of those bees as they cross state lines. So if those bees have some sort of disease or parasite, we could be infesting our own domestic hives by being so liberal in our willingness to have outside hives come in with no inspection at all. And here's what it looks like when we say we're transporting bees around the country for pollination services. This is a semi-tractor trailer fully loaded to the top with beehives. And this is the sort of mechanism we now have for taking bees from the residential home, usually in some southern state where it's warm, and transporting them literally across the country, often to California, in large numbers. And so once these arrive in California, let's say they're going to do almonds, they'll be unloaded, placed around the almond orchard. When the almond trees flower, the bees will go out and do their pollination thing. And that'll be a fairly short-lived thing. The plants only flowers for days or weeks. So at that point, when the flowers are gone and presumably have been pollinated, there will be no more food in the almond orchard for these bees. So they have to be gathered up and transported elsewhere. And so that's why they're kind of on a production schedule that follows spring and the emergence of flowers, so that they can participate in the pollination of those plants. But this is not a safe thing to do. What would happen, in addition to the problems involving inspection and the possibility of transporting disease and parasites across the country, what would happen if one of these semi-tractor trailers got into some sort of wreck? Well, sadly, it happens on a fairly regular basis. So here's a big old trailer loaded with beehives that has crashed into something, and you can see that the rig has overturned and all of the beehives have fallen off and they've broken open, and guess what those bees are doing? They're swarming the police vehicles. If I were a police officer, I would be thinking, I don't get paid enough for this. So that's what happens. And parts of this highway probably will have to be closed down so that the darn bees can be gathered up, but that means finding new hives and importing them and convincing the bees to get into them, and it's a mess. So transporting those bees long distances is hard on the bees. As I've said, it can result in spreading parasites and pathogens to in-state bees. And because a given grower, let's say a grower of almond trees, might need to import bees from multiple growers in different locations, that simply increases the probability of spreading diseases and parasites. Plus, once the food is gone, once the flowers have been pollinated, there's no food left for the rental bees, so they've got to move on, and they're going to be out there on the roads looking for new crops to pollinate and increasing their exposure to bad things like accidents that can result in a massive bee swarm. Now, Ohio, as well as other states, typically have a requirement for inspection of all hives, and this usually is directed at domestic hives. So Ohio has a requirement that all hives in the state of Ohio be inspected by a qualified inspector. But there really is no attention paid to rental hives. The concern is for those beehives that are in residence in the state of Ohio. So this means that it's entirely possible that beehives that are transported from elsewhere into the state of Ohio will cross those state lines with no inspection whatsoever. In fact, we can pretty much count on that being the case. The laws on the books that require inspection are antiquated. The law requires inspection of 2 out of 3 of every commercial hive. 2 out of 3. What about the other third, you ask? Good question. And it requires the inspection of all individual hives. So if you're a hobby beekeeper and you have only 1 or 2 hives, both of those hives have to be inspected every year. The law's on the books, but it is a joke. There used to be 5 full-time bee inspectors for the state of Ohio. They were paid a salary by the state of Ohio, and it was their job. They divided up the state into regions, and the bee inspectors were deployed to go out and cover those 5 regions and make sure that the number of inspections required by the law was conducted. But due to budget cuts, there at one point was 0 inspectors. Now there's 1 half-time person, but this same person is also the state apiarist, which is a full-time job, and she's a state entomologist, which is a full-time job, in addition to being the half-time honeybee inspector for the entire state of Ohio. So guess how many hives she inspects per year? The answer is none. So to make sure that some attention is paid to the law that is on the books, the counties in the state of Ohio are trying to fill in on the bee inspections by hiring local people to do the job. And often it ends up being a patronage job. You're the friend of the county commissioner or the relative of the county commissioner is given a salary to go around and look at beehives. But they are not well trained. They virtually to a person have no experience in entomology, and any training they get are on the job. If they file a report, they are not required to send that report to the people at the Ohio Department of Agriculture who were in charge of beehive inspections. Does this make any sense to you? No. And there are currently 16 county inspector positions open and are unlikely to be filled because of budget cuts. Say it with me now. Budget cuts are bad. But there's more bad news. More bad news. Is this possible? Yes, it is. What is this bad news? I hear you cry. Well, the state of Ohio, when it designed its beehive inspection procedures back in the day when they had 5 full-time bee inspectors, decided it would only charge $5 to inspect an apiary. Now this is $5 per facility, not per hive. So if you're a hobbyist and you have 1 hive, you pay $5. If you're a commercial operator with 200 hives, you pay $5. Not per hive, but for the whole operation. In addition, another thing that mitigates against getting an inspection is that if you do not want to have your hives inspected, if you're a commercial operator and you don't want any government official coming around looking at your bees, and believe me, for some reason, the beekeepers as a group are just irascible. They don't like government at all. They don't want government officials on their property. They really get riled, kind of like bees get riled when you stoke them. Well, so do the beekeepers. And so, by law, beekeepers who do not want to have their bee hives inspected are able to opt out of this legal requirement by filing what is called a no consent form. It doesn't have to be approved. It simply has to be filed. And if it is filed, then the only way an inspector can enter that facility and inspect those hives is via a court order. And remember that there's no budget, right? So how many court orders do you think are requested and filed? The answer is 0. And then lastly, the low amount of money that is procured through inspection, the $5 per facility, goes to the state general fund. It does not go to the Ohio Department of Agriculture or to a place that would fund future honeybee inspections. So for all practical purposes, there is no honeybee inspection program in the state of Ohio at the current time. Now, I don't want to leave you thinking that there's nothing we can do. It is rather bleak. Historically, the numbers are working against us. Things are vulnerable. Colony collapse has kind of leveled off, we think. But our experience has taught us that something will be back in the future to cause problems among honeybee hives. So what can we do to prevent future crises? Well, there are a number of simple things that we could encourage people to undertake. For instance, the hobby beekeepers who keep a single hive might consider supporting 2 or 3 hives instead of 1, and that would help quite a bit, actually, because there are an emerging class of people who are interested in beekeeping. We could also do things like educate farmers to redirect their spray boom away from honeybee hives. But of course, they have to know that the hives are there. If they don't know that the hives are there, they're not going to redirect their spray. So some sort of geographic tracking of all the hives and education of the farmers to spray the other direction would be really very helpful. We can do a little bit of work to broaden the acceptability of urban bee hives. They are not the death trap that some would have you believe. You can productively and safely deploy beehives in an urban setting. You probably wouldn't want 8 hives, but 1, with enough land around it and enough crops to keep it busy during the pollination season should make it very acceptable even in an urban setting, particularly if you educate your neighbors. Clearly, we need a proactive plan for dealing with Africanized bees. We do have people who do research who are tracking their migration north. They haven't gotten anywhere near Ohio. They might be infiltrating places like Texas, but they are not anywhere near us. Nonetheless, it's a wise idea to keep an eye on the problem, and largely academic researchers are doing this. We could arrange for those reports that are sometimes written by county inspectors to go directly to the Ohio Department of Agriculture so that they could be used for some, useful purpose, like tracking declines in bee before it becomes a crisis. I'm just saying, it might be a useful thing to do. We can also increase access to beekeeping courses. Now, sometimes these are offered, they used to be offered via OSU, not so much anymore due to, budget cuts. They are now being sometimes offered by master gardeners and those kind of people. So I think there is at least a way to increase this a little bit. And indeed, we've had more people showing up for beekeeping courses when they are offered. And lastly, we could teach homeowners to plant very simple and pretty pollination garden in their own yards. We can encourage people to put out plants that would attract honeybees, and this could assist in keeping those pollinators busy and providing the resources the honeybees need to keep their hives going. But maybe the final solution is to educate people about bees. I think it's probably the case that unless you've had a particularly enlightened teacher somewhere along the line, most of us get through our 12 years of public education without even hearing about bees. We don't know why they're important. We do know that they can sting. We do know that we're afraid of them, but we don't know what they're doing that's really useful and, in some cases, essential to us. So education, as always, is the answer. And to that end, OSU, and particularly the entomology department, of which I am a part, has undertaken a major outreach effort on behalf of bees, which we call the Pollinatarium. It's a freestanding educational building. We actually have a whole building in which we talk to future citizens and current citizens about honeybees, about pollination, why it's important, what it does for us, how we can protect bees, how you as a citizen can promote the health and well-being of bees. So in addition to the beautiful pictures that Karina Weatherby is responsible for, there's educational material. We have a live hive that's inside the building. There's a tube so the bees can come and go from the outside to the inside, and you can see them doing their thing. It's really, really neat, and I think if we can do more of this, then maybe over time we'll have fewer problems with people understanding why bees are important and why we should put up with them and the occasional inconvenience they cause us, because they're doing some really critical things that impact our economy and our ecology as a result of their pollination activities. Okay, so go see the Pollinatarium if you're up at Worcester at the Ohio Agricultural Research Facility. It's a nice way to spend an afternoon. And here is your lecture guide for module, it's actually 26, on pollination and honeybees.